Hello, ladies and gentlemen, this is Mr. Miller. Here's your Algebra 2.3 notes, solving inequalities using multiplication and division. So to start, we will be able to, obviously, with the heading, solving inequalities using multiplication and division. Multiplication and division. I'll just shorthand it a little bit there. Second thing here, we'll also use our inequalities to solve real life problems. Excuse me. So, just picking up from where we left off here, a couple of warm ups. Here, um, they want us to check whether the given number is a solution of the inequality here. So, there's a couple different ways that you can do this. We haven't really looked at solving for x to see if it falls into the actually possibility of being 20, so being an answer. So what we'll actually do with this one is to start here. If it is a solution, it will make sense on our number line. So we'll go ahead and plug in 20 into our x. And we're wondering, is that less than or equal to 7? So again, we got to do a little calculator work. If we wanted to change it to a decimal, that's how you'd use your calculator. If you want to leave it as a fraction, you can do it that way as well. For us, just looking at a decimal approximation there, which is really close to 7, is going to give us 6 2/3 or 6.7-ish. So I'll actually do 6.67-ish. That's our approximation. Is that number less than or equal to 7? And our answer is yes. 20 is a solution. So for the second one here, again, they're asking us if -6 is the solution. So we'll throw in that -6 in there. So 4 times a -6, that has to be greater than -23. 4 times a -6 is a -24. Is that greater than a -23? Now be very careful here, ladies and gentlemen. We've talked about this in some of my classes. But remember, this is all based on our number line, right? Greater than numbers go to the right. Less than numbers go to the left based off of 0. All right. So even though it might look like, oh, 24 is a bigger number, that's a less than. We're getting further and further away from our 0 here. So is -24 greater than 23? No, it is not. So that is false information. That is not true. So we usually put like a slash through that. So here is -6 a solution, and it is not. So -6 is not a solution. For number 3, says how long will it take a diver to ascend 36 feet if the average rate of ascension or ascent is 30 feet per minute? So here, setting up a little story problem for us. First things first, I like to write down some of the parts here. So we do have 36 feet that we're looking at. And then our ascension rate here is 30 feet per minute. So that is written as 30 feet over 1 minute. So we're asking here with these two, what is the rate here? So this is actually going to become a division problem where we want to get rid of the feet. So this is just one way to look at it here. Again, this is over 1, and then I wrote 30 feet per minute is written as 30 feet over 1 minute. I want to get this down to what is the rate, the average rate here. So I want to know how long is it going to take us here for 36. So I want my answer left in minutes. So for this, two ways to look at it. You're either going to take 36 and divide it by 30. That's one way to look at it. But I just wanted to bring in our units here, just a nice little view here, is that if you have 36 feet, and that is over 1, we want to flip our secondary unit there because we want to cancel out the feet. So 30 feet goes on the bottom, the 1 minute goes on the top. So we can cancel out those feet. So I have a foot on the top and a foot on the bottom. So they cancel out. So I know my answer is going to be left in minutes here. And then we simply do the 36 divided by 30, which that comes out to a decimal of 1.2, and this is minutes. Now, I do want to take this one step further. Some people would be satisfied with 1.2 minutes, but in the real world, what is 0.2 minutes? Is that 20 seconds? Is that 2 seconds? We want to make sure that we calculate this so people know this takes 1 minute and how many seconds. So we have one more conversion here. We have 1 minute, which is 60 seconds. So we're at 0.2 of a minute. So 0.2 of 60 seconds is what we need to calculate there. So we need to take that 0.2 and multiply it by 60. And that comes out to, doing it on my calculator here, 12 seconds. So to answer this question, we don't put down 1.2 minutes. We actually put down it takes 1 minute and 12 seconds. So that we all know, no matter who you talk to, whether it's in math class or not math class, you all know, oh, it takes 1 minute and 12 seconds. You're not going to go around and say it takes 1.2, 1.3. You know, you're not going to do that. Next, our notes here for our multiplying and dividing. Do a little exploration here to help us with the back side. So it says choose any two numbers and relate them with an inequality symbol here. So the two numbers I'm going to choose are 4 and minus 6. All right. So you can write this one of two ways. You can write it 4 is larger than minus 6, or you could have said minus 6 is smaller than 4. Those are two possible ways. So the numbers I'm playing around with are 4 and 6, minus 6 and 4 for that. And then we're going to apply and see what we notice here. So we're going to do all of these first, and then we'll go back and write them in over here. Multiply both numbers by 2 and then relate them. So just showing my work, I'm going to go off from this original one I just have here, ladies and gentlemen. Okay, it didn't matter which one I went off from, but I'm going to stick with just the 4 is larger than minus 6. So I'm going to take 4 first, multiply it by 2. That gives me an answer of 8. I'm going to take my minus 6 multiplied by 2, and that gives me an answer of minus 12. And then we're going to relate them. So 8, how does that compare to my minus 12? And again, if you want to go off from this one, it'd be just complete opposite there. But again, I'm going off from this first one. So I know I can start to see a relationship here. Well, 8 is larger than minus 12. Let's continue. Multiply both by minus 5 this time. So again, starting with my first number, 4 times a minus 5. That comes out to a minus 20. Then I have a minus 6 times a minus 5, which comes out to an answer of 30. So now we're comparing minus 20 and 30. Well, minus 20 is less than 30. So that's a less than symbol. All right, let's continue and we'll come back. Divide both numbers by 2. So 4 divided by 2 equals an answer of 2. Minus 6 divided by 2 gives me a minus 3. And again, I write my two answers down and compare them with an inequality. And again, 2 is greater than minus 3. All right. Divide both numbers by 1. So again, squeeze it in here. 4 divided by minus 1 is a minus 4. A negative 6 divided by a minus 1 is 6. And again, compare. Minus 4 and 6 are my two answers. Minus 4 is less than 6. All right. So, what do we notice what happens to a relationship between the original numbers and then when we're looking at multiplying or dividing those same numbers? So here, what we're seeing is that with a positive 2, whether I'm multiplying it or dividing it, my sign stayed the same way as I originally wrote down my two numbers. So my sign said it was a greater than, it stayed as a greater than. Same down here, stayed as a greater than. When I had a minus that I was multiplying or a division with a minus, my sign switched. So it was a greater than, now it is a less than. It is a less than. So here, my inequality sign stayed the same. Next one, the inequality sign changed directions. Next one, inequality sign is back to staying the same. And finally, our inequality changed directions. We'll underline the changed and the stayed. So again, this is very important for when we are solving and using multiplication and division here on the back side. So let's go through some examples here, and you're going to see what we get from this is anytime we multiply by a positive number or divide by a positive number, the sign stays the same. When you multiply or divide by a negative number, the sign needs to change. So, doing that, we have a couple here I want to go through together, and then we'll let you do a couple on your own also. So one extra little rule here that we're adding today with the sign switching. But other than that, just like I mentioned the other day, when you have an equality sign, just kind of treat it like an equal sign. So how would you solve this problem if it was an equal sign? And then we have to think, okay, are we doing with anything with negatives? So here, if this was like an equal sign, how would I get rid of this division of 3? Well, it is a multiplication of 3 on both sides. So we multiply by 3, multiply by 3. Again, that's a 3 over 1. Some people like to have that. So again, my 3 on the top cancels, 3 on the bottom cancels. So then we get x, and there were no negative numbers that we were dividing by or multiplying by. So the sign stays exactly the same direction. And 8 times 3 is 24. So I think that's my answer. We're going to graph it out. So again, I always like to use the number that we have, the positive number and the negative number. So there's where positive 24 would be. There's where minus 24 would be. This does not have an equal sign with it, so we know it's going to be an open circle on the 24. And again, if you put the variable first, the arrow tells you which way to go. So arrow head has to go to the right. So it means all answers greater than 24 should work here. So super important to check these ones, especially because we're getting into signs possibly switching here. So you want to make sure your sign is going the correct way. So we want to go ahead and grab a number that's larger than 24. So I'm going to just pick one that's a little easier mental math. So we'll say x is 27, which is in our larger than area. And we will check that. So I put in my 27 divided by 3. That has to be greater than 8. Well, 27 divided by 3 is 9. Is 9 greater than 8? And the answer is yes. So we have our sign going the correct way, and we have answered it correctly. All right. If you pick the wrong direction, so as an example here, I won't show it just because it'll get a little confusing in here with all the work. If we chose 0, 0 shouldn't work. 0 divided by 3 is 0. Is 0 greater than 8? And the answer is no. So I shouldn't have any arrow above that 0 there. We're going to let you try this one on your own, considering again, this is a positive. So you're not doing anything with any negatives for multiplication and division to help you solve this here. So take a moment to do that one on your own. We will do one with a negative. So here, same thing. Treat it just like an equal sign. So what are we going to do first to get x by itself? So it's being divided by -4. So I would have to multiply by -4 on both sides. So multiply by -4 on both sides there. Again, anytime you multiply or you divide by a negative, this is where the sign needs to switch when you're doing your work. So yes, this does clean up to x, but my sign needs to switch because we had a multiplication of a negative, so it's going to be a less than now, and then we get -48. And then we can check it. So here's 0, here's my -48, here's my +48. It says here there's no equal to sign, so again it's an open circle on the -48, and we should be going that direction with our arrow as long as your variable is first, ladies and gentlemen. Remember that we don't want to have to do double switches here, so make sure you're always putting that variable first, so when we do have a switch, we're not confusing ourselves further. Then from here, we're going to check it. So I'm going to pick a number here that kind of works out nicely. I'm going to pick 52. So we're going to let x equal a minus 52. Sorry. So that is in this answer pool. So when I plug that in, minus 52 divided by a negative 4, that all has to be greater than 12. Well, 52 divided by 4 is going to be negative over negative, positive 13. And is 13 greater than 12? And again, the answer is yes. So I know that I have my shading going the correct direction. Easy one to test, 0. This should fail. So if you plug in 0, 0 over 4 is 0. Is 0 greater than 12? And the answer is no. So again, that's an easy one to check if you want to check for the failure. All right, so we shouldn't have anything shaded above here because it's not a possible answer. All right. We will let you do this one on your own. So again, working with the negative. And we'll do one example here with this minus 6. So we'll go to that one. So here's another multiplication of a negative. So how do I undo this? Again, looking at it, treating it just like it would be like an equal sign, but we do have an equality. So if it's multiplication, that means we'd have to divide by a minus 6. Divide by a minus 6. So again, anytime you multiply or divide in your step here in your equalities, the sign has to change. So this does become n. My sign has to change greater than, and we do get a minus 4 answer. Go to my number line. So again, I like to use the positive 4 and the minus 4. And if you aren't doing this, please make sure your number line negatives are always on the left side and positives are always on the right side there. So we're doing our number line correctly. Again, no equal to sign, so it's going to be an open circle above. As long as my variable is on the left, my arrow should be pointing in the right direction. So let's check it. 0, I'm going to use that this time because it's in my answer here. All right, so this should come out to a true statement. So if we let n equals 0, so plugging that in, 6 times 0 has to be less than 24. Is 0 less than 24? And my answer is yes, it is. So I do have it shaded the correct direction. All right, on to the story problem. We'll let you, again, do those 3 there, checking your work. I will have answers posted as well after this video. This doesn't quite all fit in here, but we'll get it in. Restaurant owner plans to place identical bouquets of flowers on 35 tables for opening night. The owner wants to spend no more than $400 for all of the bouquets. Write an inequality, find the possible amounts of money, M, that the owner should budget for each bouquet of flowers. So when I have an inequality question here, I like to kind of think of it as kind of like an equal sign. So what if let's just ignore this no more than for a moment. And let's say the owner wanted to spend exactly $400. Well, how much would he have to spend on every single table for it to equal $400? So that's going to be our division problem. And then we'll bring in the secondary part there to it. So again, a couple different ways you can write this, but I'm going to start with the division. So 400, I'm going to divide that by 35. Now that would usually be an equal sign, right? but that is the maximum per table. So spend no more than. That's the maximum. So that is the greatest amount or equal to, because it's a no more than, and then we have our M here. Now, I don't like my variables on the right side because then if I start to graph this out, we might run into some problems. So I'm going to go ahead and switch it. So M is less than or equal to, and again we have this maximum number of 400 over 35. Doing a little math here, cleaning it up, simplifying it. 400 over 35, unfortunately, is kind of an ugly number. It comes out to $11.428. I'll go out 3 decimal places, even though money is only to the single cents. So that would be looking at the 2. We would not want to round this, ladies and gentlemen, because if you round up, you're making it higher, and then you're going to have spent more than $400 if you round that to 43 cents. So that's a real life a problem there. So make sure that you're paying attention that if it is talking about no more than, we can't go over that. If I have this, I can't make this 43 cents. So really, on each table, if he's keeping it equal, he can only spend up to $11.42. And again, he is spending money, so it is going to be greater than 0. He's not going to get any money back from this person, so we do have the opposite end of the inequality as well there. So what are the possible amounts? So here are the possible amounts, and this is just going to show you as a number line. So again, we got 0, minus 11.42, 11.42. It is an equal sign, so that's shaded in on the 11.42. And again, our arrow normally would point this direction going down, but remember, we're not going to get any money back from the florist. He's not just going to give us money. So it stops at 0. So open, and then shade in between those 2. Thank you, ladies and gentlemen. Make sure you do those 3 and get those checked with your checkpoints there.